Hello wonderful person, this is Anton, and today we're going to be talking about planet Earth. Or actually about a recent announcement in regards to the change in the rotation of the core of our planet. With a lot of articles kind of making a somewhat unusual suggestion that the core reversed its rotation, which as you can imagine is kind of incorrect. And so in this video we're going to be discussing what exactly happened to the core of our planet, what the scientists have discovered in this recent study, that as always you can find in the description below, obviously how they found it, and why none of this is really that exceptional, unusual, or unexpected. As a matter of fact, we've discussed a lot of this in some of the previous videos. But I guess first, a quick reminder about the structure of planet Earth. Most textbooks today will present us with something like this. We have the crust on top, the mantle right beneath it, the outer liquid core, and the inner solid core. Although even this is somewhat refuted today, as the scientists in one of the recent studies, that as always you can find in the description, discovered that there might be another structure within the core that we didn't really understand before. So there might be actually 5 different layers. But the deepest layer, and the one that's most mysterious, is of course the inner core. The super hot, super pressurized, solid ball of metal that's about 1200 kilometers across, represents 20% of the Earth's radius, and is actually even smaller than the Moon, about 70% the Moon's size. And this unusual structure that's almost entirely made out of iron and nickel actually has its own rotation that is somewhat independent of the rest of the planet. Something that was actually only discovered back in 1996. You might actually want to check out one of the previous videos in the description that mentions something else we discovered about the outer core of the planet that to some extent also surprised the scientists. Either way, back in 1996, this study right here that you can find in the description definitively confirmed that the core has its own rotation that's not necessarily aligned with the rest of the planet. But prior to this discovery, the scientists actually believed that the core was almost not spinning at all, or that a single revolution of the core might take anywhere from 400 years up to even 1,000. And so the assumption here was that the core was basically doing its own thing, with most of this driven by the balance between electromagnetism from the outer core and the gravitational pull from the rest of the planet. But here there's a really important clarification. It doesn't mean that the scientists thought that the core itself is completely stuck and does not rotate at all, whereas the rest of the planet just orbits around it. Instead, what the scientists believed is happening here is that the core might actually rotate a little bit slower, or even a little bit faster, than the rest of the planet, potentially completing a single rotation every 400 years. And that's compared to the rest of the planet that was also rotating as well. And so in other words, everything here was still rotating all together. The outside surface, the mantle, and of course both of the cores. It's just they were doing it at slightly different times. But more recently, in the last decade or so, since 2009, the scientists started to discover something unusual about the inner core. It started to dramatically slow down its rotation. And even though initially it might have been rotating a little bit faster compared to the surface of the planet, it now appeared that it basically slowed down to the point where it ceased to rotate at all. Once again, compared to the surface. If you were to look from the outside of the planet Earth, it would still be rotating, but in this case at the same velocity as the rest of the planet. So it didn't really stop completely. But these new observations also suggested that it didn't just pause, it was also turning back. Or essentially, it was rotating slower than the rest of the planet, by a tiny amount, but visible nevertheless. With all of this, very likely some kind of an effect caused by the gravitational interaction between the rest of the planet and the core itself. Also very likely because of the magnetic fields of our planet generated by the outer core. Although here the scientists discovered that this might not be a single event, this actually might be some kind of a pattern that repeats over time. Or in other words, that the rotation of the core seems to oscillate every few decades, slowing down, stopping, reversing and accelerating with a multi-decade long timescale. And in this case, it was actually the same scientists that discovered this. The same scientists that published the paper back in 1996. And they did so by tracking seismic wave readings from various repeated earthquakes, sometimes known as doublets, that traveled across South Atlantic to Alaska between 1967 and 1995. But also looking at some of the recent results from recent observations as well. So here we can see that prior to 2009, the rotation speed was a little bit different to what we observe after 2009. And overall, it does create a kind of oscillation with a period lasting approximately 65 years. Now obviously this is using some of the older data that might not be as accurate, But nevertheless, the actual results are quite interesting and quite intriguing. It basically shows us that, first of all, the inner core rotation was consistent between the 70s and early 2000s, and then started to change dramatically, stopping completely in 2009-2010. But prior to this, during the 60s and the 70s, it might have experienced something similar, although maybe on a much smaller scale. Here there's just not enough data to determine exactly what happened. But it does imply that there might be a cycle or some kind of oscillation driven by external effects from the magnetic field and possibly gravitational interaction with something else. But I guess the obvious question to ask here, does this have any effect on what's happening on the surface? Or to rephrase this, should we be worried in any way? Well, pretty much nothing here suggests anything cataclysmic is about to happen. As a matter of fact, it probably has absolutely no effect on the surface. For example, this graph right here actually shows us that right now, the core is almost entirely in sync with the rest of the planet compared to several decades ago, which are unlikely to affect the life on the surface. It's not going to increase the number of earthquakes, it's also unlikely to increase any kind of other geological activities including volcanoes, although it would be really interesting to find out if it has any effect on the magnetosphere of the planet. Since a lot of these effects are believed to be both gravitational and electromagnetic in nature due to the interaction with the outer core, it would be interesting to find out if there are any patterns or any oscillations in the magnetic field as well. At the moment, this is not known. Although here the scientists do suggest that there might be some coincidental correlation to other periodic changes on Earth, including the tiny variations of the length of the day on Earth and the slight changes in the magnetic field. We actually discussed some of these mysteries and some of these discoveries in the videos in the description, which of course suggests that there's definitely some kind of oscillation and some kind of a pattern that seems to repeat every 60 to 70 years and potentially has very minute effects on the rest of the planet. And so of course the next important question here would be, what other effects this might have? We know that there are other patterns and other oscillations on the planet in regards to sea level and even the global mean temperature, but at the moment nobody really knows if any of this is connected just yet. Nevertheless, a pretty intriguing discovery. So essentially, by observing these slight deviations in the arrival of shockwaves from various earthquakes, which would arrive a fraction of a second faster from the 60s to the 90s, with their speed changing after 2009, indicated to the scientists behind the study that the inner core very likely changed its velocity. But once again, it did not stop completely, it simply changed its rotation compared to the rest of the planet. But I'm sure we'll be hearing more about this in a lot of future discoveries, because this is actually a pretty important one, especially if it has any effects on the rest of the planet. On that note, well, that's pretty much all I wanted to mention. Check out the links in the description below, subscribe, share this with someone who has learned about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.